Hey Kipsters, today we're going to jump back into scientific notation. I want to make sure I clear up some things around scientific notation and the operations on numbers in scientific notation before we move into ninth grade. Take a second to make sure you have this page at the front of your packet and read along with me. The distance from Earth to Mars on a certain day of the year is about 40 million miles. The length of a common dust mite is 400 centimeters. You can use scientific notation to write very large numbers or very small numbers such as these in a shorter form. A number is in scientific notation if the first factor or coefficient is greater than 1 and less than 10. The second factor must be a power of 10. A power of 10 is a number in the form of 10 to some power, where n is an integer. Let's take a look at the distance from Earth to Mars in standard form. So the distance from Earth to Mars in standard form is 40 million. This number has 3, 6, 7 zeros. What do you notice about that number when it's written in scientific notation? Yeah, I noticed that the exponent for the power of 10 represents the number of zeros in that number. The zeros are considered the place values behind that first digit, which must be greater than 1, but greater than or equal to 1, but less than 10. Let's look at the common dust mite measurement. A common dust mite is 400. This is a number that's smaller than 1. When we're working with numbers that are smaller than 1 in scientific notation, what do we know about their exponents? Yeah, we know their exponents are going to have to be negative. In particular, there are 2 place values that I would have to put into this number to have a leading digit that is greater than or equal to 1, but less than 10 in front of my decimal point. So that's going to give me this exponent of negative 2. When you write a large number in scientific notation, you are moving the decimal point that number of places to the left of the coefficient. Then you're going to write that factor as 10 to some power. Let's try an example. Write this number in scientific notation. Our strategy here is we're going to write this number as a product of a coefficient and 10 to the power of n. So we want to start by moving the decimal point to the left to find the coefficient. So I'll start at the back of the number and I'm going to need to move 3, 6, 9, 10, 11 times. The coefficient, the number I want in front of my decimal point, is 8. Now I'm going to keep that whole number and I'm going to multiply this coefficient by some power of 10, making sure that n is represented by the places that I had to move to the left. Because I moved 11 places to the left, my exponent would be 11. Therefore, this number in scientific notation is 8 times 10 to the power of 11. This also works when you're working with very small numbers in scientific notation. What direction would I move if I'm working with a very small number to put it in scientific notation? Yeah, I'm going to move the opposite way. I'll be moving to the right to find the coefficient. And then I'm going to write it as a factor of 10 times 10 to the power of negative n. Take a look at example 2. Let's write this number in scientific notation. So I'm going to start at the decimal point and I want to move the number of places to the right until I have a number greater than or equal to 1 or less than 10 in front of the decimal point. That means I am going to move 1, 2, 3, 4 times. So my coefficient is 5. Remember, the coefficient is the number in front of the decimal point. Now I'm going to multiply this coefficient by a power of 10, making sure that my exponent is negative. Remember, I moved 4 places to the right. So I'm going to use a negative 4 as my exponent for my power of 10. Therefore, this number in scientific notation is 5 times 10 to the power of negative 4. Take a look at example 3. In example 3, the population of the United States is expressed in scientific notation. Our instructions are to write this number in standard form. What does standard form mean? Yeah, standard form is the typical way a number would be expressed. Standard form shows us the entire value of a number. Because this is a number already expressed in scientific notation, I need to put the place value into these numbers. How many zeros would come behind this 3? Because the exponent is 8, I'm going to move 8 places to the right. So that means I'm going to have 8 zeros after this 3. Therefore, the population of the United States in standard form is 300 million. Look back over any of these examples. If you start to get confused, be sure to come back. Let's go ahead and jump into some classwork. Are the following numbers written in scientific notation? If not, please state the reason why. So if a number is written in scientific notation, all you have to do is say is yes. If a number is not written in scientific notation, tell me no and explain why not. Yes, exercise number 1 is written in scientific notation because there is one digit in front of the decimal point that is in between 1 and 9, and it is multiplied by a power of 10. Let's look at number 2. Exercise number 2 in scientific notation. No, exercise number 2 is not in scientific notation. Which of the criteria from the box above or from the explanations I've been given show us that this number is not in scientific notation? Yeah, my leading digit. The coefficient cannot be equal to 0. This number must be greater than or equal to 1 or less than 10. Continue through the rest of the answers and make sure you enter them into Edpuzzle for credit. When you're finished with the packet, be sure to turn this in.